Today in this video, I will be discussing differentiation of inverse trigonometric functions. But before that, let me just remind you that this is the 8th video in the series of differentiation. If you have not seen other previous videos, please watch them as well. Links are given in the description box below. Alright, let's first quickly revise all the basic differentiation rules and standard derivatives, as these will be used frequently throughout calculus. So we have derivative of sum of functions, which is just the sum of individual derivatives. Similarly, the derivative of difference of two functions is just the difference of individual derivatives. Similarly, the derivative of product of two functions is given by the product rule, which is first function derivative of second plus second function derivative of first. When a function is in the rational form, we use quotient rule or division rule. And the rule is denominator into derivative of numerator minus numerator into derivative of denominator whole upon denominator square. Now let's have a look at some of the standard derivatives. Derivative of x raised to the power n is nx raised to the power n minus 1. This is also called power rule. Differentiation of e raised to the power x exponential function, it's same as e raised to the power x. Differential of a raised to the power x is a raised to the power x ln a. Derivative of ln x is 1 upon x. Derivative of trigonometric functions, sin x is cos x is minus sin x. Derivative of tan x is sec square x. Derivative of cot x is minus cos x square x. Similarly, derivative of sec x is sec x tan x, and derivative of cosec x is minus cosec x cot x. So as we are aware that for 6 trigonometric functions, we have 6 inverse trigonometric functions as well. And these functions are given as sine inverse x, that's how we write them, or arc sine x, where x belongs to minus 1 to 1. It's a closed interval. So x belongs to minus 1 to 1, the domain. Similarly, cos inverse x is, or it can be written as arc cos x, where again x belongs to minus 1 to 1, and so on. So similarly, we have tan inverse x, sec inverse x, cot inverse x, and cosec inverse x also. So the inverse trigonometric functions with their complete domain, range, and all graphs, I have already covered these in a previous video. The link will be available in the description box. Now at this moment, let's focus on the differentiation of inverse trigonometric functions. Now let's see the derivation of sine inverse function, the derivative of sine inverse x function. So let's say y is equal to sine inverse x. So x is equal to sine y. We can write it as x equal to sine y. If we differentiate it with respect to x, then it gives us 1 is equal to cos y dy by dx. So from here I can write it as dy by dx is equal to 1 upon cos y, can be written as 1 upon cos y, and we know that this cos y is also written as 1 minus sine square y. Cos y can be written like this also. And now we know that sine y, from here we know the value of sine y is already as x. So substituting this value over here, it's 1 upon under root of 1 minus x square. So the derivative of sine inverse x is coming as 1 upon root 1 minus x square. Now very interesting thing to note here is that this derivative dy by dx, this will only exist when this cos y, that means the denominator, is not equal to 0. Because for this derivative, if 1 upon cos y, if cos y becomes 0, then this derivative will not exist. Now this cos y should not be 0, which means if I write it as cos y, y is actually sine inverse x. So it is cos of sine inverse x. So this derivative will exist only when this denominator is not equal to 0. And this sine inverse x will not be, sine inverse x should not be minus pi by 2 or plus pi by 2, because if it is minus pi by 2 or plus pi by 2, then then this cos will become cos minus pi by 2 or cos plus pi by 2, which is a zero value. That's why the sine inverse x should not be equal to minus pi by 2 or plus pi by 2, which means this x should not be equal to minus 1 or plus 1. So this clearly indicates that the domain x must belong to minus 1 to plus 1. So this completes the derivation. The derivation of sine inverse x, the derivative of sine inverse x rather, should be 1 upon under root of 1 minus x square, where x belongs to minus 1 to plus 1. This is the list of all inverse trigonometric functions and their derivatives, and the respective domains of all the derivatives are also given. It means this, the derivatives, where are they valid. Also, one very interesting thing to remember is all those formulae, they are based on a particular pattern. For example, you can see sine inverse x and cos inverse x, the derivative is same. Tan inverse x, cot inverse x, the derivative is same. The only difference is with cos inverse x there is a negative sign, with cot inverse x there is a negative sign. Similarly, sec inverse x and cosec inverse x, the derivative is exactly same. The only difference is with cosec inverse x there is a negative sign. So one hint to remember these formulae: whenever we have co in the inverse trigonometric functions, their derivatives are all negative. So if you remember and recognize the pattern like this, it will be easy to remember these formulae. Now, when we are solving the questions, at times it is really helpful to substitute x something like this, then the question becomes very easy. So these are called standard substitution, and if you remember them, it will be a great help while solving the questions. So for example, if the expression in the question is like something under root of a square minus x square, then try to substitute x as a sine theta or a cos theta. Similarly, if it is a square plus x square, try to substitute a tan theta or a cot theta. If it is x square minus a square, then probably a sec theta or a cosec theta will help. Similarly, if we have the expression like a plus x upon a minus x or a minus x upon a plus x, we should try a cos theta or a cos 2 theta to solve the questions. These are some hints, and it makes the question really easy. Alright, now let's try to solve some questions. For example, if we have a question like y equal to sine inverse x square, and we have to find the derivative of this. The question is find out the derivative of this. So obviously, since it is a sine inverse function, we know the derivative of a sine inverse function is given by 1 upon under root of 1 minus x square. That's the formula. So here it is x, that's why in the formula x square is coming. But in our case it's not x, we have x square. So similarly we will make the change in our formula also. So dy by dx should be equal to 1 upon under root of 1 minus x square. Now we have solved the sine inverse thing. So as per the chain rule, now into I must find the derivative of x square. So I'm finding the derivative of x square. So solving it completely should be 1 upon under root of 1 minus x raised to the power 4 times 2x. So this is the answer, 2x upon under root of 1 minus x4. Another question is, suppose y is equal to tan inverse 3x plus 4. Very similar, 3x plus 4. So again, this is not in the standard form, so we will be using the chain rule again to find the total derivative. So dy by dx is equal to, now look at it from the outside, tan inverse x, and the derivative of tan inverse x is 1 upon 1 plus x square. The only thing I should be careful is when I am writing 1 upon 1 plus x square, I will not write only x, rather I will write 3x plus 4 whole square, and after that I have derivative of d upon dx of the rest of the thing, which is 3x plus 4. Now simplifying it, it is 1 upon 1 plus, let's open this, it should be 9x square plus 24x plus 16, all in the denominator, into derivative of 3x plus 4, which is just 3. So if we complete this, should be 3 upon 9x square plus 24x plus 17. So this is the final answer for this question. Okay, let's take another question. For example, y is equal to e raised to the power 10 inverse cos root x. So not a standard question, not a e raised to the power x type of question. So to differentiate it, we definitely will have to use the chain rule. So dy by dx is equal to, first of all, look at it from here. This is e raised to the power x type. So obviously e raised to the power x, the derivative is always e raised to the power x. So tan inverse cos root x. Now I have solved e. Now what is left? Tan inverse cos root x. So this means it is d upon dx of tan inverse of cos root x is now left after that. So continuing, this will remain as it is, e tan inverse within bracket it is cos root x, and now we are differentiating tan inverse cos root x, and we know the derivative of tan inverse x is 1 upon 1 plus x square. So obviously it should be 1 upon 1 plus x square. What is x? Cos root x. So it should be cos root x whole square. Now tan inverse is also solved, so we are left with derivative of cos root x, and the derivative of cos root x should be minus sine root x. So this way we have solved cos root x also. If cos is solved, now we are only left with root x, and the derivative of root x is 1 upon 2 root x. So all derivation is done. Now we just collect all the terms together. So it is minus sine root x minus sine root x times e raised to the power 10 inverse cos root x, as it is cos root x, and then the whole thing is then further divided by 2 root x times 1 plus cos root x whole square can be written as cos square root x. That's it. So this is the final answer in that case. Alright, let's take one more question to differentiate. Suppose we have something like y is equal to tan inverse, and then within bracket we have 1 minus cos x upon sin x. 1 minus cos x upon sin x. This is another question, and the objective is we have to find out dy by dx. Okay, so interestingly, if we see the numerator here, in the numerator we have 1 minus cos x in the numerator. So this is a hint in calculus, especially whenever we have 1 minus cos x or 1 plus cos x, the hint is we should always try to substitute that value of cos x which will cancel this one. Now we know that in trigonometry cos x has multiple formulae. For example, it is cos square x by 2 minus sine square x by 2. This is one of the formula. Similarly, we have 2 cos square x by 2 minus 1. This is another formula. These all are half angle formulae. Similarly, we have 1 minus 2 sine square x by 2. So given, as per the given condition, out of these two, one will be selected over here. Now in this case, in our case, it is 1 minus cos x. So the cos x is already negative. So I must go ahead with this value, because this will make my this one as negative, and it will be able to, I will be able to cancel it with this one. So this is a hint which should be used in questions like this. So I'm writing tan inverse. Now it is 1 minus, in place of cos x I'm going to write that formula. It is 1 minus 2 sine square x by 2 from here, and divided by, in the denominator again half angle formula, in place of sine x it should be 2 sine x by 2 cos x by 2. So just writing both of them, 2 sine x by 2 cos x by 2, and completing this. Now if we open the bracket, it is tan inverse Now 1 minus 1 will cancel. I'm opening the bracket. 1 minus 1 will cancel the 1. Minus minus plus. So I have 2 times sine square x by 2. Similarly, in the denominator also I have 2 times sine x by 2 cos x by 2. This was the half angle formula for sine x. That's how we have written it this way. Now this 2 and this 2 cancel. One of the sine x by 2 is cancelling with one of the sine x by 2 over here. So we are left with tan inverse within bracket sine x by 2 upon cos x by 2. We have tan x by 2. Now again in trigonometry we have a rule that tan inverse of tan x is always x. All these formulae are covered in my previous video where I have discussed the inverse trigonometric functions, so you can go through that. Now tan inverse of tan x by 2 as per this should be equal to only x by 2. So actually I am left with this question. This question actually turned to just y is equal to x by 2. And since the objective was to find out dy by dx, so let's go ahead. Finding dy by dx for x by 2 will give you just 1 by 2 because the derivative of x would be 1. Alright, let's take another question. We have y is equal to tan inverse under root of 1 plus cos x upon 1 minus cos x. This is very similar to the previous question which we just did right now. We know that in these questions the trick is we must substitute that value of cos x which will cancel 1, and two such possible values are 2 cos square x by 2 minus 1, or it can be 1 minus 2 sine square x by 2. So depending on the position of the sign, negative sign, we should select the appropriate formula over here. So it is tan inverse under root of, in the first case it is positive 1, so I need a minus 1 here, so I should go with this formula. So I'm writing 1 plus 2 times cos square x by 2 minus 1, and the whole thing is then divided by 1 minus bracket. Now the value of cos x is 1 minus 2 sine square x by 2. Now simplifying both of them, I am still getting tan inverse under root of, if we open the bracket, you can see this minus 1 and this plus 1 cancel. If we open the bracket here, this one and this one cancel. So in the numerator left with 2 cos square x by 2, while in the denominator left with minus minus plus, left with 2 times sine square x by 2 again. So this and this gets cancelled. So this becomes tan inverse of under root of cos square x by 2 upon sine square x by 2 is actually cot square x by 2, which should give you tan inverse of just cot x by 2. Now it is tan inverse of cot x by 2, and this is still y. So y is equal to, now tan inverse cot x by 2 can be written as tan pi by 2 minus theta. Basically pi by 2 minus theta is cot theta, so this I am writing pi by 2 minus theta. Theta is x by 2. So understand which formula I am using here. It was actually cot theta, and we know cot theta can be written as tan 90 minus theta or tan pi by 2 minus theta. So that's how the cot is converted to tan. Why? Because we know the formula now which is applicable is tan inverse of tan x should be equal to x. So based on this formula, I'm getting y is equal to just pi by 2 minus x by 2. Pi by 2 is a constant, and minus x by 2. Now since I have to find dy by dx, so differentiating both the sides, pi by 2 would be 0, minus x by 2 would be just minus 1 by 2. So the derivative of this expression is just minus 1 by 2. So this is all about differentiation of inverse trigonometric functions. Well, if you could understand what I was trying to explain, please like and subscribe to my channel. And if you want to be notified for my next video, please press the bell icon also. Thank you.